Before starting locus, let's understand different properties of quadrilaterals. We will look into different types of quadrilaterals like rhombus, square, rectangle, in general parallelogram, and we will understand the properties that you may be already aware in your basic geometric class, and we will apply those concepts to solve any problem. In fact, you can use those concepts to solve this kind of problems also. The proof that points belongs to a particular type of quadrilaterals. So let's begin. So first one is parallelogram, and I'm not going to prove any of those properties. So when I say parallelogram, whatever properties I will tell, those will be applicable to all kind of parallelogram, right? Square, rectangle, rhombus. All right. So parallelogram is basically where opposite sides are parallel and equal in size. All right. So first important property that you can apply in this coordinate geometry is diagonals bisect each other in parallelogram. So let's note down diagonals bisects each other. So the length will be, it will divide in equal length. Second property is very obvious, pair of opposite sides are equal. To prove that these points forms one parallelogram, you can easily prove that the midpoint of these two vertices, this point and this also, is same point. Let me write that. Midpoints of diagonals meet at same point. We'll be applying this concept in solving these questions. Let's move to rectangle and square. No need to explain what is rectangle and square, you already know, right? So when I say rectangle and square, all the properties of parallelogram will be inherited in these shapes, right? In this case, diagonals will obviously bisect each other. The first point is angle will be 90 degree, right? Rectangle or square. Second property, the important point is diagonals are always equal in rectangle and square. This is equal, these are all equal. To prove that any shape is rectangle, right? How can we prove that? This is enough to prove that the diagonals are equal. If we just prove diagonals are equal, this is good enough to prove that the shape is rectangle. How to prove any shape is square? You can prove diagonals are equal. Also, you need to prove that all sides are equal. All right, let's move to rhombus. Rhombus is also parallelogram where all sides are equal. This is just the tilted version of square, right? If you just tilt it, this will become rhombus. The first point is all sides are equal. Second point is, this is interesting, diagonals bisects each other at right angle. All right, so this diagonal is always 90 degree. Also, diagonals are angular bisector. That means this angle is same as this angle. All right, in a recap, let me just recap. In all kinds of parallelogram, diagonals bisect each other. This is good enough to prove that midpoints of diagonals meet at same point. In case of square and rectangle, diagonals are equal. In general, diagonals are not equal, but in case of rectangle and square, diagonals are equal. In case of rhombus, diagonals bisect each other. Obviously, it will bisect each other because this is a parallelogram. It will inherit all properties of parallelogram, but along with that it bisect each other at right angle, and there is one more property: diagonals are angular bisector. Let's start with the first question. If the points x1 y1 x2 y2 x3 y3 be three consecutive vertices of a parallelogram, find the coordinates of fourth vertex. Alright, so three vertices are given. This is what? This is parallelogram, right? A, B, C, D. Let's name it x1 y1. This is x2 y2. This is x3 y3, and we have to figure out x4 y4 in terms of x1 y1 x2 y2 x3 y3. How to find that? We can simply apply the concept that diagonals bisect each other in parallelogram, right? So this point will be meet at the same coordinate, right? So what is the midpoint of AC? x1 plus x3 over 2, and that will be same as x2 plus x4 over 2. So simply it will come as x1 plus x3 minus x2, right? Similarly for y also, y1 plus midpoint, right, equals same as y2 plus y4 over 2. Simply y4 is y1 plus y3 minus y2. Alright, so this is the answer. X coordinate of fourth vertex and y coordinate of fourth vertex. Let's move to next question. In any triangle, prove that AB square plus AC square. I think we can ignore this. This is not related to quadrilaterals. Prove that the points are vertices of a parallelogram. Is it a rectangle? Let's plot. The point is 3, 2. B is 6, 3. C is 7, 6. And D is 4, 5. So what we have to prove? This is parallelogram or not? To prove that parallelogram, we have to prove that diagonals, the midpoint of diagonals bisect and meet at the same point. So what is the midpoint of this one? AC. The midpoint of AC is 3 plus 7 over 2. Is this same as the midpoint of x coordinate of the midpoint of BD? Is it same as 4 plus 6 over 2? This is 5, this is 5, right? So x coordinate is matching. What about y coordinate? 2 plus 6 over 2 is 8 over 2 is 4. Is it same as this? 5 plus 3 over 2. That is also same. So this is definitely a parallelogram. To prove that this is a rectangle, what you can prove? You can prove that diagonals are equal, right? And we can easily figure out using distance formula, right? What is AC? AC is what? 3 minus 7 is 4. 4 square is 16 plus 2 minus 6, 4. 16 plus 16. And what is BD? BD is 4 minus 6 is 4 plus 5 minus 2. This is also 4. So this is 32. You can simplify it, but these are not same, right? AC is not equal to BD, and hence this is not a rectangle. You don't need to calculate the distance of AD, BC, AD, AB, BC, CD. You can simply compare the diagonal length. These are not equal, hence this is not a rectangle. Moving to next question. This is proof that the points are vertices of a rectangle. Again, same question, similar type of question. You can just show that if diagonals are equal or not. A is 4, 8. 4, 8. B is 0, 2. C is 3, 0. D is 7, 6. Let's see the midpoint of diagonals. Not midpoint, we need to just, what was the question was? Rectangle, right? To prove that rectangles, we need to just prove that diagonals are equal. Okay, what is AC? AC is 4 minus 3, 1 plus 8 square. that is 65. All right, what is BD? The length of other diagonal, 7 means 49 plus 6 minus 2, 4, 16. That is also square root of 65, and hence this is, yes, this is a rectangle. The last question is prove that the points 4, 3, 6, 4, 5, 6, 3, 5 are vertices of a square. Let's apply the same concept that we discussed. To prove that any shape is a square, what we can prove? First we can prove that this is rectangle, right? Means rectangle means diagonals are equal, and then we can prove that all four sides, the length of all four sides are equal. Let's do that quickly. A is 4, 3, B is 6, 4, C is 5, 6, D is 3, 5. Length of diagonal, what is the length of AC? AC is 1 plus 9 square root of 10. What is BD? Is 6 minus 3, 9 plus 5 minus 4, 1. These are same. That means this is definitely a rectangle. And to prove that this rectangle is a square, you can just see the length of each side. That is easy to calculate, right? AB is what? 4 minus 6. 4 plus 1. That is square root of 5. BC is 6 minus 5, 1 plus again 4 square root of 5. DC is 5 minus 3 is 4 plus 1. This is also square root of 5, and AD is 4 minus 3, 1 plus 5 minus 3, 2, 4. So hence this is square. So all these 4 to 5 questions were very easy one, but the concepts are very important, right? Rhombus, you need to understand that diagonals are angular bisector, it bisect each other at right angle. Rectangle diagonals are equal, right? And parallelogram diagonals bisect each other. So this concludes the topic of coordinates. In the next video, we will look into locus, and once locus is done, we can formally start straight line. See you in the next video. Bye.